Hello, welcome to this talk that will focus on presenting a real-time architecture with the world's fastest database in Azure. That's the title. So my name is Luís Marques. I'm the CTO of Link Red Blue, and also my colleague Samuel Ramos, that is a data architect in the same company. So we are focused on leverage the value of the data with expertise approach, and our motto is fluent in data. Okay, let's back to the presentation. So the title of presentation, as I said before, is exploring real-time architecture with the world's fastest database. And yes, you guess it, it's Cosmos DB. Okay, so we're going to talk about Cosmos DB. Cosmos DB, less known, unique features. We'll also have a live demo in the end. And we'll try to show you what is using Cosmos and what is Cosmos delivering this unique experience on processing data. Okay, so before we go directly to the modern architecture, we're gonna just have a single slide regarding the NoSQL hype. Why is that? Because we talk a lot of hype in this IT, okay? So NoSQL was no exception. So add an hype pattern. So we started in around 2000 with use cases of Facebook, Twitter, Google. The first papers of Facebook start to appear at this time. So the age base. The second step of the hype is like what we call the 2 months, and it solves every problem you have. It will not be like that, of course, and it's called the peak of inflated expectations, of course. Around this time, it appeared MongoDB. That is nowadays is a very established database. Fast forward until 2015. In 2015, we have the real disappointment. So use cases didn't fit the NoSQLs. NoSQLs were not very mature at the time, or we realized that we cannot replace relational databases with all the relational databases with NoSQLs. So they need to coexist. One solves one problem, other solves another problem. Fast forward a little bit, also in 2017, we have the appearance of DocumentDB that is now called Cosmos, and also DynamoDB from Amazon. And today we say that the hype is completely off and we are on the plateau of the productivity. So a lot of well-known use cases, well-known features. We know when to use it. So we're going to help you to explore all these features during this presentation. Okay, let's go. History done. We did a little bit history. I hope it was clarifying. Before we go directly to architecture, we would like to put you on design pattern for event-driven architecture, because we're going to show is an event-driven architecture. Okay, so we have usually when we talk regarding design patterns of event architecture, there are a lot of talk on this, of course, but usually we pick these all 4 design patterns. Okay, so the first one is the event notification pattern. This happen when a system sends an event message to notify other systems in case of changing of its domain. Okay, there's a key element on this event notification pattern, that is the source system doesn't really care about the response. Okay, so this is very common for all the systems that process events. Okay, so the second one is event carry state transfer pattern. The name is quite big, but it's basically the event notification pattern on steroids. And that means that you transfer, you carry it with you in all events, all the history of previous events. Okay, so that allow you to not need to have the source, to query the source to get the state of the system. Okay, this is a little complex, and usually is not very well done at real world level. Okay. The third one is something that you eventually, if you deal with microservice and so on, is something that you already and is CQRS. CQRS is basically the common query responsible segregation. Is when you have separate data structure for reading and write information. You have a read model and a write model, and they have different purposes, and they are modeling in a different way. But we're gonna do the fourth one on our demonstration, event sourcing pattern. Okay. So what is the event sourcing pattern? So every time you have a single change in the system, you generate an event. Every single time. You can see on your right on image order service, every single time you have a change in your order, or it is created or approved or shipped or complete or paid, you generate an event. So you have all the events in event store, let's call it this way. And then you can have a lot of consumers to consume all this data, okay? So one thing that is very, very cool on event sourcing is because you create all these events when there is some change in the system, and because the events are immutable, okay, this event store acts as audit log, okay? It will be possible for you to reply all the past events, or just for audit purposes to go through these events, okay? So also events and consumers are completely decoupled. So we're gonna explore a little bit of an architecture with this pattern, okay? Next. Okay, so let's go event sourcing real time. I'm going to show an architecture. Okay, so this can look a little bit complex, but the example is building the future store that will sell a lot of tickets. Let's imagine that you sell a lot of tickets, that you need some scalability on this, and you also sell marketing, t-shirts, and so on. Very busy store. Okay, it's an architecture that provides Cosmos as a central piece, and we'll explore some unique features. One of the features that we're going to explore a lot is change feed, okay? And also we're going to explore Cosmos DB triggers. Also we're going to explore Azure functions. That is not a feature of Cosmos, but is very tight and integrated. And our architecture is basically the path of order that you make on the building the store, building the future store. Okay, your order gets created, your order gets approved, your order gets paid, your order is completed, and every single change on the order, the consumer will be notified and will be process that order. For example, you create the order. So there is a microservice that detects that on the change feed and will do the approval of the order. Okay, this is what we call event sourcing architecture. Okay, so move on. We're gonna go a little more. Wait. So wait. Why wait? So we have a lot of features. I'll talk a lot about change feed, triggers, functions, and so on. This is a complex topic, but we're going to start slowly on Cosmos. First, the resource model. Quite simple: accounts, database, containers, and items. Okay. Other accounts is your Azure account. Databases is, you think as a namespace. You can think as a namespace. Okay. And the container is the most important unit. Okay. So it's a unit of scalability for throughput and for storage. Okay, so the containers are usually horizontally partitioned. Okay, and you will see that with the importance of defining the partition key. That is, let's say, the most important decision we'll ever make on Cosmos. Okay. Also, these containers will be replicated across different regions. Okay, and in the end, you have items. Items is basically JSON documents, or what we call JSON. Okay. One thing that is on here also, there is Cosmos supports different APIs. We are going to focus on SQL APIs, but it supports Mongo API, Cassandra APIs, and Graph APIs, and so on. And there is some differences on the naming. Okay, you can see if you go through Mongo API that it's called collections instead of containers. Okay, but let's keep the focus on SQL API. Okay. Another thing that is quite important is partition. So I said before, this partition is mandatory when you create a container. Is the most single important decision you make when you're designing our architecture that contains this kind of database, on this case Cosmos. Okay. Usually, you need to have a very, very detailed understanding of your data, so you can pick a partition that have the most distinct values on it. On this case, we pick user ID as example. Usually, this is the contrary of relational databases. Okay, so the items that you have to the container will be automatically grouped on logical partitions. Okay, so Luis will have a logical partition, Samuel will have a logical partition, Maria will have a logical partition, and this logical partition will be distributed across physical partition based on the partition key. Okay, we're gonna go through the partition on the last slide a little bit more and the importance of it. Okay. Second, RUs. So this is the consumption unit that measure what you pay for Cosmos and also your throughput. Okay, for reading 1 KB of data, you need 1 RU. Okay, just keep in mind that reading it's more simple than writing. Writing a document implies that you need to update, index it, that consistent levels will affect the amount of RUs that you need. There's a lot of factors that you need to take in consideration when calculating the throughput and also the consumption of your Cosmos DB. So JSON size, of course, if you have a document of 10 KB or 20 KB, it will take much more RUs to process and to write and to read. Okay, so also your query complexity is also a major problem on a major factor on your RUs consumption. Okay, the change feed. So this is, I'd say, this is the most important feature of Cosmos. It stays behind every single container and watch for changes that you need to do, that you need to know. Sorry. Every time you do an order and you have a new order, it captures the new order. You update the order, you update the JSON, it captures that update. Okay, so it maintains a persistent record of changes in the order they occur. Okay, so there is a lot of use case for the change feed. I'll not go through them here, but what we're going to explore on our architecture and our demo is basically how to consume the change feed and react to the change feed. Okay, second thing about the change feed is, if you understand, as soon as you create an order, it creates a new JSON document. Change feed will understand that, will listen for that change that create, it will capture that create. The Azure function will be triggered, and as soon as that change will be on the change feed, it will read from the change feed and will process the order and change the status to approve. Okay, this is it looks complicated, it's quite simple. Okay, any change you do, the container will generate an event to the change feed that you can use functions, microservice to consume that. Okay, so you can see an example, order status change for new to approve. Okay, second, nothing is Azure functions. So Azure functions are not really a Cosmos DB features. It's a serverless compute service, as you eventually know. You can run event-based trigger. On our case, it is used for as soon as you have the new event on the change feed, it will react to that particular event. A thing that is quite important on this is you can scale Azure functions. You can have 5, 10 Azure functions reading from the same lease container. Okay, so you can have a scale on your microservice or your consumption of events. Okay. Triggers. Okay, triggers are coupled with functions. It's basically an old term. What I want you to understand here is the lease container that you need to understand that it maintains the state across Azure functions or consumers. If you have 10 consumers on 10 Azure functions, you will need a lease container that creates a checkpoint and the state across the consumption of the change feed. Okay, so this is only supported on SQL API. Okay, so this is an example of DB trigger, quite easy, like static code. This is quite simple. Let's move fast. So people used to say that, okay, we have all these features that are very interesting, but I'm really scared of NoSQL. And why? Because most of the time they think that data modeling is art. Okay, I'd say that's not art, but it's different that you are used to. Okay, so how we model the data, we're gonna through a little bit on this. So most of the data is relational. There is nothing changed here. Okay, all your data that you are dealing is relational. Users relational with orders, order relation with shipping, and so on. There's nothing changed on this. Relational databases store data in rows. Non-relation usually store data in documents or JSON. Okay. There is nothing you cannot store in a row that you can store in a row that you cannot store in a JSON document. Please make sure that you understand that. Also, make sure that you understand there is no joins between the containers, and there is no foreign keys and no primary keys. Well, there is unique keys, but there is no foreign keys. Okay. So the question is Cosmos DB really suitable for relational workloads? And the answer is yes. Otherwise, we'd not be doing this talk. Why? Why it is? So why it is? So we usually pick the two rule. So the two rule is basically the two rules of modeling data in Cosmos and the NoSQLs in general. You have the rule embedded and reference. Before that, I would like to make sure that you understand that it is the Cosmos is scalable and non-relational. Okay, so we need to apply different techniques. It's not okay to understand that the container is like a table. It is not. It's a completely different thing. Okay, so when we have a relation one-to-few or one-to-one, like a user and their address, like you see on the image or on your right, it is one-to-few or one-to-one because one user usually have one address. Okay, and typical you do embedded. So you create a JSON document with embedded addresses and user attributes there. Also, when entities are typically queried together. Okay, so if you query your user, you usually want to know their address, and if you query together, it's much faster on the performance level to have that in a single document. Just make sure that you also understand that you can have multiple type of documents on the same container since they share the same partition key. Also, reference is one-to-many. You need to do, like, if you have 400, 500 order types, you cannot, of course, put that embed that on the single document together with the user, for example. It doesn't make sense. If you want to create a lot of order types, different ones, and it's unbounded, you don't have control how many you have to reference. And for that, usually a technique that is similar with the relational database, you create an ID and you use that for the join. Okay, remember that you can have different documents on the same container that share the same partition key. Okay, so this is the last slide, I guess. So the importance of partition. Already said as the partition key is the most important design decision that you make. It will affect your performance. It will affect your queries. It will affect the consumption of RUs. It will affect your design and your architecture. Okay, so pick a partition partition key that have a lot of distinct values, not like relational database. Pick one that is an ID, for example, like here, customer ID that we picked. So on this, we have logical partitions that group data according to the partition key, and that maps to physical partition. Please remember that physical partitions are not the same as logical partition. So logical partition is based on customer ID, and that maps to physical partition. So two logical partition can be on one physical partition. So you don't control that in Cosmos, but it's controlled by Cosmos. So when your partition is known, Cosmos DB will route your query directly to the physical partition, having a millisecond latency on this. It's quite impressive. It's very fast. If the partition is not known, so it's a cross-partition query. Okay, if you query, for example, for user ID or so on, it will be a cross-partition query. So we'll verify all the partitions under that, and that will increase the amount of areas. Okay, so I think from my side, it's done. Okay, we'll move to the demo to my colleague Samuel that is on the call. And Samuel, it's your turn now. You can share the screen.
Okay, thank you, Luis. Now we'll demonstrate an architecture for the topics that you maybe have mentioned in this presentation, very related with the Cosmos DB. And for that, we have a sample use case for an e-commerce architecture. Imagine an architecture for your e-commerce business that it's composed by 5 common microservices: the orders microservice, the warehouse microservice, the customers microservice, the payments microservice, and the notifications microservice. And all these services are centralized and exposed to your web interface, to interface of your website, your web store, through an API gateway. And one possible way to implement this quite interesting architecture is by using Cosmos DB as a store of our data, of our web store, and together with Azure Functions. And we also can include the Azure Notifications Hub, and by example, the Azure API Management for having a complete whole scenario of this architecture, although these two microservices, the layer of the API management and the notifications hub and the payment service will be not a subject of this demonstration. This demonstration is more focused to demonstrate how you can implement this kind of architecture using Cosmos DB together with Azure Functions. Specifically, Azure Functions, we use the Cosmos DB trigger that reads from the change feed, and we also use Azure Functions HTTP trigger that it's a way to expose an endpoint to other consumers. So we show you here a way to respond to events with Azure Functions and a way to respond to remote procedure calls with Azure Functions HTTP trigger. And to start this the implementation of this architecture, I will show to you what you can see on Azure Portal for the Cosmos DB instance. And by now, I have three different databases here in Cosmos DB, and I'm using the Data Explorer view. And I have three databases, three different databases, one for the holding orders, one for customers, and one for the warehouse. Think of these databases as the data store of the microservice that I mentioned earlier. The data orders is the database for the orders microservice. The customers is the database for customers microservice, and warehouse it's the data store for the warehouse microservices. And here, by example, on my customers, I already have two different documents, and my partition key here is the document ID. And by now I have two different clients. Under settings of the container, I can see things like the time to live for the documents that I have configured, how the data is replicated in Cosmos, the partition key that I configured. The partition key must be defined at the moment you create your container. So, like Luis mentioned earlier, you have to take a very important decision when creating your container, because you will not be able to change the partition key after that. Sorry. And you also have the indexing policy, and that for the purpose of this demo will be the default one it's the default one, and will be indexing all the attributes of our documents. And like Luis mentioned, you can take a decision and only index the attributes that will be most suitable to you and will improve the quantity of argues consumed in each query. And for this demonstration, we also have the Azure functions. This is the look and feel for an Azure function that will be reading from our orders container. Our orders container at the moment has orders as five different orders, and what we'll be demonstrating for this demo will be the creation of a new order by a customer, for example. And this order will be read from our Azure function. This Azure function is in .NET Core on top of a Windows flavor. And here we have a function. And this function will be listening for updates over the change feed of the orders container. And the idea here will be the creation of a new order that will fire an event of a payment. Once the order is created, will be raised or triggered a new event for the payment microservice, and then the payment microservice will proceed with the validation of that order and approve or reject that order. So here it's the log of our Azure function. This Azure function is connected to our orders change feed. And what I'll be doing here is simulating the creation of a new order. So creation of a new order as attributes the customer ID, the shipping address, the IDs of the products that will be in the order, and the payment method. So I will be calling this web service at order trigger, that it's an Azure function that it's exposing this resource on Azure. So if I call it, I will get an answer, and this answer told me that an order was created with this new ID and the state is new. And if I go back to my log, I see that a new document arrived at my change feed, and this new document for what I can see, it's on the waiting payments. So in real business, this the Azure function will be firing an event to a payments microservice. And since for purpose of this demonstration, I will be simulating the behavior of this microservice. And for that, I will get the information that could be sent to this microservice in order to go forward with this event. So I can see that this order that I just created is in the waiting payment state. And now, if my payment microservice will answer to this new order with an accepted payment, like the example below, the payment was accepted, and if I do a new get for the states of this order, I will be able to know that the order was waiting for processing, and once the order is in waiting for processing, the Azure function that is listening for the change feed finds the waiting processing state will move forward the processing of the order. We put together the products and do the shipment for the customer. That will be, in the end, the order will be then updated to process it. Once the order is processed, it's then closed. And all of this is possible to see on the logs of my Azure function. This Azure function is very focused to order updates. And by example, I also have another logs connected that it's now empty because I wasn't refreshed this window before. But in order to show you just some code and to finish the presentation, like Luis mentioned before, to listen for a change feed collection, it's so simple as putting the name of the database, the collection name, and the connection string of your Cosmos DB instance. The most important is the list collection name. This is all the state of the reading of current read for Azure function. If you have more than one Azure function reading from the same change feed, you have to also add the list collection prefix. And since I have two different Azure functions reading from the same collection, from the same container, I have to define a prefix for updated orders, and I also have another sample that it's also reading from the orders container that is called the waiting processing orders. That way, I can have multiple, in this case, two different Azure functions reading from the same change feed. And also for the sake of your interest, I also have here a sample of how I do the HTTP triggers. That it's looks like very similar to the Cosmos DB trigger, and in this case it's a post, and what I'm doing is processing the request body that I received on my HTTP request, convert it to an object, and then save it to my Cosmos DB container. And that, very quickly, it's a way to implement this e-commerce architecture and implementing this architecture in a scalable way, and taking into account an event-driven architecture. Thank you for your time, and this is part of things we do here at Link Red Bull.